Right, that's the recording on. Thanks for being here. I just did the head count, it's about 22 people are here at the moment. I'm just kind of taking a note of that so I get an idea as to how many are making it to the lectures versus watching the recordings or not, perhaps, as the case may be. So we're going to start today by concluding the lecture material for this week. So that's just one more lecture on JavaScript stuff, which once you've done this, you'll basically know all that you need to know for the rest of the course, with a couple of small exceptions. So basically, we've crammed a whole JavaScript programming course into 1 week, and it'll be sufficient for most of what we require. Then, of course, we'll move on to the tutorial, where we'll look a bit at your ongoing homework exercise or any questions that you have. So that's the plan. Okay, let me just check. Yeah, recording's looking okay. So on Monday, I went through the kind of rudimentary parts of JavaScript and told you enough of the language syntax and enough about the kind of type system and so on that you would be able to do the homework exercise. But that's not the whole story. There are a few extra things that you'll need for subsequent weeks of work that I'm going to tell you about now. So that's under the heading of fancy stuff. So one example of fancy stuff that we haven't really looked at explicitly yet is objects. JavaScript is an object-oriented language. On Monday I told you a bit about numeric types and strings and arrays, which, if you remember, turns out actually they secretly are objects. But now I'm going to talk about like proper objects. So as you'll know from your other languages, from JavaScript or C++ or whatever, if we're going to create objects, we probably need to start by, creating a new class, and then maybe creating public and private attributes and methods, and then creating a constructor, and then using that with the new operator to create the object. No, you don't. In JavaScript, it's a lot simpler than that. In JavaScript, it's actually very easy to make new objects. And the way you do it is like this. If I want to create a person object, I say person equals, and then I just put what I want the object to be in curly braces. So let's say we have, so you know what objects are like, of course, they've got various properties, attributes, fields, different words are used in different languages, they're all talking about the same thing. The properties are just the internal memory of the object, the things that it knows about. So a person would have a name, that seems like a reasonable claim, and the syntax for this is the name of your attribute itself, followed by a colon, and then the value of the data. So this person is me, so we'll give it my name. And that's one field, and the other field is age, which at the moment, God help me, is 47. How did that happen? And if I do that, that creates an object. So notice no specialized separate constructor. I guess this whole process is like an inline construction. No class declaration, no real kind of boilerplate or anything. You want an object, here's an object, and it just makes it. So there you go. And again, you can inspect these inside the dev tools, and it lets you see a little bit more about what's going on, including some secret stuff down here that we'll talk about in due course. So that's how you make an object. Having got this thing, we can now do standard object things that we can ask it about its properties. So we take person and we say, what is your name? And it'll just return the value. That's nice and easy. We can also use the array-like syntax, which is just a different way of doing the same thing for the most part, which is where you use you use the square brackets, and it's the same trick, except that the field has to explicitly be a string when you do it this way. So you put it in quotes, which I didn't have to do up here. Grammatically, it wouldn't be, the language wouldn't let you say dot quote. That would be invalid syntax. But when you do it this way, when you're using this, as I say, a kind of array-like syntax or a table lookup syntax, whatever you want to call it, you can basically do the same query. But
this also allows you to look up things that have keys that have more than one word.
Yes, one of the advantages, this way is actually, first of all, it's hard to see why this is a good idea because I have to type more stuff, right? I have to type more letters and it's more things that can go wrong, but it turns out this will allow you to create names that, for a start, you could have computed by some other process, and it'll allow you to create names of things that syntactically you couldn't do by putting after a dot, like numbers, which aren't allowed up here. Which is why for arrays you have to do it this way, you put the number in. Okay. And just to show the what's actually going on here, the matching is strict here. It has to be case sensitive. So if I'd said name instead with a capital N, that would be a different field, and this object doesn't have name with a capital N in it. So like everything else, that was just the auto incorrect, as I like to call it. Okay, undefined because there was no such element. And that's just standard JavaScript stuff for you. Now, as I just explained, this syntax of using the kind of, I'll call it array style lookup for want of a better term, allows you to do some things that otherwise wouldn't be quite so easy. So you could have a piece of code where you compute the property that you're interested in. And let's say you end up deciding that you wanted to know the name, and now you could just say, person, I'm interested in property, whatever it happens to be. So this is not looking for a field called property, right? If you wanted that, you'd do property, but this is just saying use the property variable as your index into this object, and it does what you'd expect. So one thing to say about this type of object, where the object is really just a cluster of some data, right? It's a bunch of data fields, pat47, and names for them, is the kind of thing that other languages might call a dictionary. Like in Python, you'd call it a dictionary, or a lookup table, or a hash table. You know, they're all sort of the same thing. And that's really how objects are in JavaScript. You should think of the object as just a lookup table, a bunch of related things that have been packed together. They've got names down the kind of the left side here before the colon, and they've got values, and it's a name value lookup system, and that's really all it does. Okay. Sometimes when you've got objects, you want to assign them to, you know, copy them, compare them, do standard things that you might want to do with any type. So let's take, let's do this thing here. So I'm creating a new variable called me, and I'm assigning it to person. So remember, the way JavaScript works is it's a reference-based language. So what this is saying is create a new variable called me that is a label or a pointer, or however you want to think about it, or a reference, which is what the language calls it. Create a new thing called me that's a reference, and assign it to the same thing that person is currently looking at. So you get person over here, which is pointing to the object, and you say, me, I want it to be that same thing. So now me and person are both looking at the same guy. Okay? And because that's the case, because they're the same object in memory, if I was to say, is me equal to person, the answer would be yes, because we've got absolute instance equality between the objects. If, however, an imposter was to come along that was trying to pretend to be me, oops, not that way. Okay, so it's exactly the same sort of thing as I did before. You look at me and you look at imposter. Can't really tell the difference. They've got the same fields and the same values. So what would happen if I said, is imposter equal to me? Anybody? No. False, right? Because it's not exactly the same object. It happens to look very similar, but it's not the same object in memory, so they're not the same, even though to the naked eye they look the same, right? That's just the way it works. It actually turns out that the rules for comparing objects in the true sense in JavaScript are a bit annoying. I've got a reference to them in the slides that you can look up, but we'll get to that in due course. In fact, if you actually care, I can switch back to the slides at this point, which is what I've been working through. So this is just what I've said here. So if you want to know about object comparison, it's actually a little bit tedious. There's an entry in here for the double equal and the triple equal operator. The strict one is the one that we'll mostly care about. And it will explain what's actually going on when you do the comparisons. This turns out to be slightly annoying though, because if you're doing things like a unit test, how many of you know about unit testing? Has that become like a fashionable thing that you get taught? So unit testing is just this idea of when you're developing software, you maybe try and write some functions that are intended to test the functions you're actually developing, and it just says call the function with these arguments and check that the answer is this. But imagine if you're doing that with an object and you want to check that it generates a pat object at the end. It wants to generate something that's got a name and an age. You can't just do a direct comparison because it won't work. You have to check each element or do some other way of creating a comparison. That's slightly annoying. It also means that if you want to clone an object, like if you wanted to create, instead of having, just now I've got me and person, and those are two variables that both point to the same object, but what if I wanted to create like a new independent copy of me over here? An assignment statement doesn't do that. It would have done in C. Assignment in C is like a copying operator, but in JavaScript it's this referencing thing. So if you want to clone things to create independent copies, it involves a bit more work. Luckily you don't have to do it that often. Let's go back to the interactive thing for the next bit. Okay. Just to show we get our bearings again, let's show you what person looks like at the moment. Okay. And so we've got person and me, which are both exactly the same thing. Imposter, which is a copy that looks similar but is actually different. So if I now take me and take my age, as it will be this time next week, stick a 1 on the end of it, and now you'll get me, it's 48 as you would expect. What about person? How old will person be?
Same.
Yeah, yeah, it will be because they were both the same thing in the first place, right? So this is why it's important to know whether you've got two copies of a thing or two references to a single thing, because if you mutate the single thing, both variables will see the change, and that's what happens here. Whereas imposter, being a separate entity, is still the way it was. So now we can kind of see why, if you do me equals imposter, it was false before and it's false now, and it will kind of always be false because they're not really the same object. They might, at a certain point in time, they might look the same because the values might match, but that would just be a temporary thing. They don't have identity, we call it. So this is a test for identity matching. Right. So we created this object and we did it nice and simply just by, saying the properties that we wanted it to have, and that was that. But JavaScript is a very dynamic language, very flexible in lots of ways. So I can actually do things like taking an existing object and adding new fields to it at runtime, which you can't do in a lot of OO languages. Normally you've got a class, and the class kind of rigidly defines what properties your object has got, and you declare those at compile time, and at runtime you can't do anything about it. But JavaScript lets you do things like creating on-the-fly additions. So I can do that, and now me is indeed, it's got 3 fields. That's the way that works. Another important thing to remember about objects in JavaScript is that in addition to being, they are basically lookup tables, values and names and values, but they don't come in any particular order. When you print them out, there's an implied order, which might be the order that you specified, or it might be some other random order. The point is the language doesn't guarantee that, so you shouldn't rely on it. If you rely on the order being any particular way, it'll break sometimes because the implementations are allowed to change that order anytime they want. For efficiency reasons, they might do that. They might turn out, internally, they might change the hash function, and if they change the hash function, the order in the list will become different. So you shouldn't rely on ordering. To illustrate that, if I create a brand new object, and give it a bunch of different types of thing, let's say it's got a field called foo, the value of which is going to be just the string foo, and we'll say that it's got an element 3, that's a 3 and a 2 and a 2. It's a very boring object. And so this is just a mixture of strings and numbers, of course. And you'll see that when it comes out, it's not in the order that I put it in. It happens to have sorted it numerically in ascending order down here, and then it's put the strings at the end. No guarantee about that. Different browsers will potentially do it differently. The same browser will potentially do it differently from one upgrade to the next, potentially from one moment to the next. There is no guarantee, and if you rely on ordering, it's technically an error, and it'll, one of these things you'll get away with it up to a point, and then all of a sudden you won't get away with it, and things will break. So don't do that.
Can you rely on ordering specifically in arrays?
No. I think the answer to that is it actually depends how you iterate them. Because if you iterate, the thing about an array is that an array really is just an object under the hood. So if you just do it in the dumb way, no, I don't think you can guarantee the ordering. But in practice with arrays, what you do is, of course, you write a for loop. So the for loop goes through 0, 1, 2, 3, and that way you're looking them up in the order that you've chosen to look them up in. But if you were to just print the array out, it's a different case. There's maybe a slight chance that there's some rule there, but I wouldn't want to bet on it. And also, there are two things I'm not going to teach you about, but there's the for in and the for of operators in JavaScript.
For each.
Oh, it's for each as well, yeah. So there are a couple of operators in JavaScript that iterate over objects. The history of this is kind of complex. If I'm remembering correctly, for of is the old one, and it doesn't guarantee the ordering. But for in got added in ES6, and for arrays it does guarantee that it will traverse in the right way. But I would suggest just stay clear of both of them because they're error prone. Just use simple old-fashioned for loops. That's what I do. I'm kind of on the fence about that. Part of me thinks, you should use the ES6 features now that they're stabilized. But when I was originally doing all this, they weren't stabilized. So you'll see that I tend to avoid the ES6 features, which is a little bit old-fashioned, but that's just the way I've chosen to do it for now. Okay, so that was objects. And as we said last time, it turns out arrays are really just objects, right? And that turns out to be an important thing to understand. So I'm going to go back to arrays now that we know a little bit more about them. So if I create an array, so what I really want to do here is, I'll reproduce what we did last time, which is create an array that's Apple 99. Oops. Yeah, right. That. And then I mucked about with it and created an element 5 that was pair. So now we've got 3 elements at the front and a little gap of 2 empty elements and a pair. Okay. And if I expand that, you sort of see the internal contents. So what's happening here is not unlike the object Pat. So Pat has got a bunch of fields, age, job, and name with some values. The array has got a bunch of fields, 0, 1, 2, and 5, that have got values. It's just got an extra thing called length. And when you print it prints it out using the square bracket thing, which you can think of as like a shorthand for it counting through, element 0, element 1, element 2, 3 and 4 are empty, element 5. Right? So it turns out they're actually very similar under the hood. So I can do other things with arrays. I can take element 2, which is currently cherry, oops, and I can make that be, anything, including another array. So if I do that, that just generated that little individual element, and if I go and look at A, you can see that it's an array that's got an array inside it, and totally legitimate thing you can do. Arrays are, they're a heterogeneous type, as we call it in JavaScript, which means it can contain things of different types, including arrays themselves. And if you zoom into this now, you'll see that under the hood, we've got an element 0, 1, 2, and element 2 is itself an array that's got its own length and its own stuff, so it's nested, it's a recursive data structure. Yes, okay, so let's have some more fun, and let's mutate this array in a different way. And let's take element 2 and make it be person. If we do that, this is just the individual element that I copied, so that's just simple. But if you go back and look at array itself, you see that the array has now got, instead of where it previously had an array of 3 elements in here, it's now got an object. and if you drill into it, you can see what the object is. So now we've got an array that contains an object that's got some other magic, and that's how that works. Let's go back to, so remember that the array, it's kind of an object-like thing, but it's an object that happens to be indexed by numbers, whereas, this thing over here is an object that's indexed by words like age and job and name. But this is the same idea, but it uses numerical indices. At least it normally does. But because arrays are actually objects, I can do horrible things like this. I can create a new element, just like I would with an object. And I've actually mutated the array and added a field to the array called crazy. So it's the craziest element instead of like element 2, element 0, element 9, element crazy. What does that look like? Well, when you print it out, this varies from time to time as to whether the IDEs show you it or not. It used to be that they wouldn't show you the elements that didn't have numerical indices, but it does now. And if you drill into it, you can see the secret internal thing. So now we're starting to see the truth a bit more, that this array thing, it's like, yeah, okay, it's sort of a special case, but it can have these non-numerical indices, which, you by the way, you don't want to do this, generally speaking, right? But these are the kind of things that can happen because the language lets you do it. So I'm telling you because it's good to know, because it's often good for debugging. This is the kind of thing, if you make a mistake, you can end up putting phantom elements inside your arrays and being confused as to why they're there. In fact, a particularly unpleasant version of that would be that if you took your array and you decided that you wanted to have a 1.5th element because you were silly, or you had been doing some floating point math to work out your index, and it had a slight rounding error in it and it wasn't quite the integer you expected it to be, and now you get that. And again, luckily it happens to show it to us here. As I say, sometimes in the past, if you did this, you wouldn't even see these elements; they'd be invisible, and you'd have to drill into them to see what was going on. So this is kind of horrifying that we now have an array with fractional indices, and I mean it works. It's like you can look it up, So what is element 1.5? So when people tell you that JavaScript is a strange language, this is the kind of thing they might be thinking about. And I mean, it gets worse. You can be, this just generalizes to all sorts of silliness. So you can, of course, have a pi element. There we go, the pith element of my array. Brilliant. What other silly things do you think you could do with array elements? Anybody? Bueller? Does anyone get the Bueller reference? Please tell me you get the Bueller reference. How many people get the Bueller reference? Only a couple. So the rest of you have not seen Ferris Bueller's Day Off. Okay. Your second homework for this week is to watch an old film from the 80s called Ferris Bueller's Day Off.
Showing your age.
Yep, I certainly am. You can do that if you were insane. So I've got an array with negative indices. It's done a line wrapping here, so you can't quite see it. But yes, there is a -5th element. Now, again, you try that in another language, it would either be, depending on how strict your type checking was, maybe it's a compile error. Most likely it's a runtime error. If you do this in C and you put a negative array index, it will actually try and work it out, but it means it will run off the front of the array into memory that you haven't allocated, which will be full of random nonsense, and may either crash your program or it will just produce junk. But in JavaScript, it doesn't do that. This doesn't fail. This doesn't corrupt memory. It just creates one of these. And this is when you realize, so this array is not what you think an array is. It's not just a bunch of boxes, 0, 1, 2, 3, 4, right? It's an object. It's a bunch of names and values. It's just that the names are generally happen to be numbers. But they don't have to be, and that's why we can do stupid stuff like adding ones that are not numeric, or ones that are not integers, or ones that are not, real numbers that aren't even reasonable fractions, and negative ones. Was there a question about that?
Oh, I was just going to say, it looks like it's just like a hash map. And, if you don't specify a key, it just defaults to the integers.
Yes.
That's basically what's going on.
That's exactly what's going on, yeah. So, and I think historically the way this must have worked is that when Brendan Eich was creating the language, he knew he was going to need objects, and he wanted his objects to just be hash tables. So he did that, and then he kind of retrofitted arrays inside that, because if you've already got objects, you can kind of see that, all I need to do with array is array creates an object where the fields are 0, 1, 2, 3, 4, and that's what he did. And that's why you get this weird thing where, remember, the type of array is indeed an object, and this is kind of the big clue as to what's really going on. You want a bit more fun with arrays, or are you getting tired of it? I don't know. Let's take element 10 of the array and make that be equal to A. Now what happens? The universe explodes. Boom. Is it actually even showing it in here? It's maybe had the sense to not try and display it. Is it there? Where is it? Somebody see it?
Array 11.
Oh yes, it is. It's put it in there somewhere. And in fact, yeah, put it in a kind of weird position. If you zoom into it, you'll see what's going on. It's put all the numerical ones down the front. You see how it's kind of, the order's a bit weird, right? It's tried to put the numerical ones in order, except not the negative ones, because blah. And then it's put the text ones at the end. So element 10 is in fact this array itself, and if you zoom into it, you see element 10 is this array itself, and if you zoom into it. But theoretically speaking, I'm not using infinite amounts of memory when I do this, because it is just looping back to itself. So if I keep chasing it, I can chase my tail forever, and I'll never catch it. But I'm basically just looking at the same object over and over again. And again, you can do this kind of thing if you're crazy. So again, none of this is recommended behavior, but it's just so that you understand what's really going on. And as I say, it's useful for debugging. Or occasionally you might want to do this. You might want to create a weird recursive data structure. Okay, so I think I can go back to the main part of the slides now. So the upshot of all those things I've just told you is that JavaScript has got some eccentricities. Yeah, this is how I did the object inspection, but that's okay. Done all the array mutation. Oh, hold on. Yeah, that's okay. We can go back to this. I'll just talk you through the rest of it. So I think that's kind of the last little quirky stuff that I need to show you right now. So having seen all that, we can maybe just summarize some of the differences between JavaScript and Java, if you're thinking of Java as your kind of reference case. Yes, dynamic typing. JavaScript has got this thing where when you create a variable, the variable doesn't have a type. The variable can point to anything, integer, string, objects, arrays, whatever. The things that it's pointing to have got types. You can say what is the type of a thing, but the variable itself doesn't really have a type. You don't declare it as being an integer variable or a string variable, and that's called dynamic typing. And there's a mixture of languages in the world. Some are dynamically typed, some are statically typed. JavaScript is a dynamic one. Okay, so here's other examples. Python, Ruby, and Lisp all work this way, but Java itself and C and C++ are statically typed, where you declare a variable, you have to say what type of variable it is. And by the way, does anyone know why you do that? Why do some languages insist on statically typing the variables?
So you can give compile time errors, which JavaScript cannot.
Yes.
Optimize.
Yeah, and optimize variable sizes.
Yeah, I think those are the correct answers. One of them is it's a way of sort of avoiding error. If you declare up front what type you think something is going to be, and then your program mistakenly, let's say you've got, an array that's supposed to be an array of people, right? And by mistake you end up putting in a vehicle into the array that's supposed to be an array of people, right? In a dynamically typed language, it'll just let you do it, and then something will presumably go wrong way down the line. A statically typed language will say, no, you can't do that. You've got your types wrong, and it can usually warn you about it when you're compiling the code as well. So it catches the error earlier. The other thing is it can be more efficient as well. If the language knows ahead of time what the types are, it can optimize memory layout and various other things, so it can be faster. You'll find that statically typed languages often have a reputation of being a bit more performance efficient. Okay. Yep, so that's just the way it works. I don't think there's you can argue in favour of both strategies. They've got pros and cons, and I think the reality is we've got a mixture of both types of language in the world, and I would say the reason for that is that they both have their merits, but neither one is clearly better than the other, so we end up with two different ways of doing it. So as you've just seen, JavaScript has objects, but it doesn't define them via classes, or at least it doesn't have to. You'll notice that I created some objects there, and I didn't create a class. And originally, JavaScript did not have classes in the language. It does now. They added something in ES6 that lets you create kind of more conventional-looking classes. That was basically a concession to people who came from class-based languages who kept thinking, wait a minute, I want classes, give me the classes. But JavaScript took a different route. It's worth realizing that object orientation does not imply classes. It's probably true to say that most OO languages do have classes, but it is not the definition of object orientation to have classes. The definition of object orientation is to have objects and a notion of message passing between the objects. And you can do that without classes. JavaScript actually got its idea from a language called Self. It was created in the 80s that used prototypes instead of classes, and that's the way JavaScript works. So the idea in JavaScript is that an object, instead of being an instance of a class, it's basically it's seen as inheriting from another object, which is its prototype. So, and every object's got a prototype that it basically copies its behavior from, and then it's got some custom things. That ends up being quite similar to what class hierarchies are like, but it's not exactly the same. The other thing about JavaScript objects is that they are associative arrays, or maps, or dictionaries, or hash tables. The concept exists in most languages, and in JavaScript they just call it an object, and they're basically just dynamic lookup tables. So they just have name value pairs. The name has to be a string, with a slight caveat that in the case of arrays it's a numerical index, but generally speaking with an object the name field is a string object, so that it can do a fast string lookup on it, and the value can be anything, including other objects or numbers or whatever you want. And yes, you can dynamically mutate them. So this again is a dynamic language feature that once you've created an object, it's not cast in stone. You can add and remove fields from the object after you've made it, which is unusual, and statically typed languages and class-based languages don't let you do that. So I just mentioned this a minute ago, that instead of most object-oriented languages have got this idea there's a universe of objects that you create at runtime, and you create them from classes, and the classes are kind of a sort of more abstract thing. The classes relate to each other, but they basically exist in compile time, and the objects exist at runtime. JavaScript mushes all that together, so it's all just objects, and the thing that you used to think of as a class becomes a prototype, except in ES6, where you can say class, but it ends up basically it's basically kind of syntactic sugar that creates the prototypes that you would have had behind the scenes. It's a little bit eccentric. Yes, so when you create an object, you can give it a prototype, or it will have a default one if you don't specify what it is. The default one is just the object prototype, and the prototypes behave a bit like parent objects or classes would have done in a more conventional language. The other important thing about JavaScript is it really likes so-called first-class functions. So this is the idea that a function is an object in the language, just in the same way that an integer or a string is. So you can create them, you can pass them around, you can store them inside arrays, you can do all that kind of thing. So that's very flexible. And other languages like C don't really let you do that so much. In C you can have function pointers, but that's not quite the same thing. It's not quite as flexible. So this fact that JavaScript lets you create functions on the fly and treats them as natural data types in the language, some people would argue that makes it a functional language. Do you know the distinction between functional languages and other types of language? Anybody know what I mean? A couple of you. So there's some languages that are called function. Oh, the word's kind of annoying, right? Because in English, functional has a common meaning of means that it works effectively. So all languages should be functional. You don't want dysfunctional languages, but that's not what is meant. Functional languages are ones where functions are the central idea. It's all about, like a mathematical function. You put some inputs into it, and it produces some outputs, and it will do so consistently and reliably. So they're based on a kind of a mathematical conception of functions, as opposed to being based on objects, which are have got internal state and mutate over time, and that's like a different paradigm, right? So some people say that JavaScript is quite friendly to functional programming because it's got a couple of the features that you need to make that work well. And in fact, it turns out if you've got functions, you can use that to build other things that you might think would have to be in the language to begin with. So one thing about JavaScript in its original form is it doesn't have like private modifiers, so you can't create private data members inside an object, as you can do in C++ or whatever. But it turns out with functions you can basically simulate that. There's a thing called a closure that exists in programming languages where you're using a function as a way of wrapping up a piece of data, and it means you can actually simulate having private members even though the language doesn't natively provide them. Numbers. JavaScript is pretty simple when it comes to numbers. Instead of having integers and floats and doubles in the way that a lot of other languages do, JavaScript just has one numerical type, but the thing to remember is that numerical type is in fact double precision floating point. So things that look like they're integers aren't really. They're double precision ones that just don't have anything after the decimal point.
Yeah, I was just wondering, when you are doing arithmetic with numbers that are all supposed to be integers,
Yes.
and you might run into like weird floating point stuff.
Yes.
Is there a native way of enforcing them to be integers, to tell JavaScript that these are integers and they're supposed to stay that way?
So not absolutely explicitly, but you can do things that are good enough. So the math object has got members in it, like a round and trunk and stuff like that. So you can, if you're doing an operation, you want to make sure that the result's an integer, you can do math.round on the value, and that'll force it to round it to a whole number representation. If it's one of these things where it went off by like 0.0001 because of a weird thing, you can use rounding to fix that. But you have to be explicit about it. And it only works up to the natural limits of the thing, as you saw yourself. If you create like a super large integer that actually is too big for double precision numbers to represent it adequately, you will simply lose precision on that number. But that would be true in other languages. Like even if you've got a language that does have integers in it, they tend to have a limited size. The 32-bit or the 64-bit. So if you put like a totally huge number in, you'll overflow your integer type on normal languages, and the range of doubles is very large. So it's not as if they're actually any worse.
Yeah, but there are ways there are obvious ways, for example, to check for overflowing.
Yes.
But if you, for example, go into two large integers for some reason, and you don't know that you've done it, this might not be a good way of checking.
It could get difficult. Theoretically, there are things you could do to check whether a floating point number is outside the range that is safe for integers. In fact, I'm pretty sure that there's also a max int value inside the math object, math.maxint, which is the highest safely representable integer that won't start to suffer from floating point.
Isn't it an integer? But I think it just returns infinity or minus infinity.
I don't think it's infinity. No, I think it will actually return like a super big number. You can check if you like. I think I'm correct there. And if not, if you really had to do it in a program, that's what you would do. You would create a way of testing that your number was within the safe range. That's a subtlety though that you're not going to have to worry about too much. But it's good that you think about it. Okay, error checking. JavaScript basically doesn't do error checking. That's the way you should think about it. And that's partly because of its intended role of it would run inside web pages. It's not pre-compiled, and those web pages are going to be looked at by, Joe Average, who's just visiting a website and doesn't want to look at compiler error messages and couldn't do anything about them anyway. So what tends to happen with JavaScript is that it doesn't really give you error messages very often. It tries to accommodate the various daft things that you do as best it can, often in slightly silly ways, and that's just the way the language is. So your debugging experience with JavaScript tends to be a bit different, that you don't have the compiler to kind of hold your hand or warn you about the daft things that you do. What happens is JavaScript will just say, right, fine, I'm going to ignore that extra parameter that you passed, or I'm going to ignore the fact that this thing is obviously the wrong type, and you'll just experience things going wrong, and you have to debug them to figure out where you made your mistake. That's just the way it is. Yes, I think it's fair to say that JavaScript gives you enough rope to hang yourself with. Which is actually kind of weird because it's sometimes presented as like a simple language for amateurs, but because it doesn't do a lot of hand-holding for you and it's got all this kind of dynamic behavior, in a way that's quite sophisticated. Like you need to know what you're doing. It's just really easy to mess up. So it's that kind of odd tension. Languages that try to be very simple are sometimes prone to quite subtle failure modes when you push them outside of the comfort zone. All right, so there's some stuff you can read about this in your own time if you want to catch up. Again, Mr. Crockford is quite good, so he's just got a nice overview of the basic elements of the language. We'll maybe revisit some of this in later lectures, but don't need to go through it just now. So the other thing we need to talk about just a little bit to get on with what we're doing is the role of JavaScript inside the web browser. So a very simplified version of how web browsers work is that you type a URL in to your address bar, and the browser goes away and connects to that server and downloads the HTML and stores it locally. Once it's got that, it parses the HTML, which is all your angle bracket, head, body, H1 stuff, right? It parses all that into a tree structure in memory, which is basically how these nested things operate. So it turns it into a tree. Then there's a process where the rendering part of the browser walks through the tree and tries to work out how big all the parts of the page need to be so it can resize them and position them around and all that kind of thing. Once it's done that, it creates a display list so it knows which parts of the text are flowing around images and things are aligned and if you've got style sheets and all that stuff. And then eventually that display list gets painted onto the screen and you get colored dots on your screen. Okay, so that's the basic idea. So what does scripting do? Well, scripting kind of gets into the flow paint part of that loop. And the idea is that once the page has been drawn, if you then do something like, you move your mouse or you click a button or the various things that you can do locally, those generate events inside the JavaScript loop. And in response to those events, it can change the structure of the tree and it can redraw things. So that's why you can interact with a JavaScript page and it'll change, it can move things around. That's what's going on. So a scripted browser works like this. It uses the kind of flow process to work out what it should be drawing. It paints the things. Events come in usually from you by moving the mouse or pressing keys or something. That triggers some script code to run, and then that changes the thing and it reflows and redraws it, and that's how it works. And if you want to make this happen on your own web pages to make them interesting, this is kind of what's going on. You have the basic HTML stuff here, where you maybe have a page that just has got a title and nothing else in it, or a little div element which has got no contents. If you want to include a script, you use the script tag and you tell it where to go and fetch the JavaScript, and then that basically plonks the JavaScript code inside your web page and now gives you the potential to react to events and do things to modify the page. So here's an example of that kind of thing. Go JS Fiddle again, which is what you'll be hopefully a little bit familiar with now from the homeworks. So you can see that what's going on here is I've got a simple page with a div element, a bunch of JavaScript that's being kind of pulled in, and it has got the ability to go and pull things out of the document. I think I showed you a bit of this on Monday, in fact. So you can manipulate the document so that you can have code down here that computes things that weren't sort of typed in by the original web designer, and those can be dynamically spat out onto a web page. So, embarrassingly simple, but it's worth understanding this isn't just a web page that says 25, 100. Right? It's a web page that's running a program that's calculating those things interactively. Okay, let's talk a little bit about JavaScript. Opinions on JavaScript. So again, we go back to Douglas Crockford, and his assessment of the language was that in JavaScript, there's a beautiful, elegant, highly expressive language that's buried under a steaming pile of good intentions and blunders. The best nature of JavaScript is so effectively hidden that for many years, the prevailing opinion of JavaScript was that it was an unsightly, incompetent toy. I would say, yeah, that's what people used to think. The reputation of JavaScript has improved a lot in recent years, in part because it's changed and in part because the world has changed and we've all just got used to it. So it's gone from being this kind of slightly embarrassing, hacky mess to being a thing that we sort of grudgingly tolerate, and it's had some of the rough edges smoothed off over time with some improvements to the language, and it's become what it is, and we're just going to have to live with it. So here are the things that Crockford thinks are good about the language: functions, loose typing, dynamic objects, object literals. The bad thing, global variables, but we tend not to rely on that so much, so that's kind of a wart that's hidden away. This other claim, which Crockford makes, not everyone agrees with this, but I think it's interesting. He claims that in some ways JavaScript is more like a Lisp or a scheme under the hood, even though it's got C-type syntax, which is an interesting way of thinking about it. In his book, JavaScript, The Good Parts, Crockford does criticise various parts of the language that he thinks are misfeatures that you should try and avoid or be very careful with. In fact, he describes some awful parts, which he lists as follows. Global variables, we'll talk in the future about why they're kind of a bad idea. The scoping rules were not great to begin with, although they're slightly better now. If you know about the let construct, that makes the scoping of variables a bit more rational. The semicolon insertion feature, again, convenient for people who aren't used to programming languages, but it can go wrong, so he dislikes it. Various other things, Unicode support's not great, some eccentric behaviours here and there. Yeah. There are lots of things about it that he doesn't like, which you can, if you find a copy of that book, you can look at his more detailed explanations. But there are things about the language that are maybe not brilliant. And then those are awful parts, he thinks. And here are parts that are just merely bad, which is less than awful. The double equals thing, I said, just don't use double equals. It does the wrong thing. I'll actually explain why in a minute. There's a construct called with in the language that, again, tends to be error prone, so don't use it. There's a way of evaluating arbitrary text as code, but it's got security problems and various other deficiencies, so it's generally avoided. A few other bits and pieces. The behavior of switches is slightly unusual. So there are a couple of eccentric things here and there, not all of which I hate as much as Crockford does, but I'm just throwing the list at you. So here's why the double equals thing is not a good idea. Right? The problem with double equals is that, remember I've told you use triple equals, which is just does the thing you would expect. It just says to these two things, are you the same object in memory? Double equals tries to be clever and tries to resolve type ambiguity. So if you say, is the number 0 equal to the string 0? It kind of says, well, if the string 0 was a number, or if the number 0 was a string, what string would it be? It'd be the string 0, right? So it's like, spiritually speaking, they're the same. And it's like, this is terrible, sloppy reasoning, but that's the way the language is spec'd initially. So it says things like that are true. Even worse, 0 is also equal to the empty string. I think the rationale there is that, well, if you took the empty string and you said, if you turn it into a number, what number would you turn it into? And it's like, well, if you had to pick one, I guess it would be 0. So that's what it does. So that's true as well. And fair enough, if 0 is equal to empty string, then empty string is equal to 0. That is, like, comparatively speaking, sensible. Like, if you switch them around, it should be the same answer. That's great, except when you go down here, and now you compare the empty string to the string 0, that's false.
Isn't it because the number 0 and the empty string are both equivalent to false? They're falsy values. Yeah,
I think it's...
0 isn't.
I'm not sure whether the actual underlying logic is about falsy values or if it's just the general business about stringifying numbers. They might end up being the same way. But here's the killer thing. Double equals is not transitive. You know what transitive means as a property in maths? So transitive means that it's like if you say if A is greater than B and B is greater than C, that implies that A is greater than C, right? That's a transitive relationship. It kind of goes down that way. Not all relationships are transitive, but it's nice mathematically for things to be that way. Inequality should be transitive, right? If A equals B and B equals C, then A should equal C. But the behavior of the double equals thing is not transitive because if you actually follow this through, you'll see that we've got, what is it, like that double quotes is not equal to the 0 string, but double quotes is equal to the number 0, and the number 0 is equal to 0 string, right? So we've got a equals B, B equals C relationship, but A equals C is not true. So when you do, and that's really horrible, if you're doing like a sorting algorithm and you're trying to compare the relative values of things, and you can't guarantee that, A equaling B and B equaling C implies that A equals C, then your sort algorithm is going to fail. So it's a really terrible property. So don't do it, use the triple equal ones instead. So what we do in practice with JavaScript to work around these things, use the safe subset of it. Basically, don't use the awful parts, and I've tried to mostly not tell you the awful parts. The bad parts that you kind of can't avoid, but you have to live with them, use them with care. And there are also tools called linters that you can use, a little thing you can run on your JavaScript code that warns you about some of these errors. If you look in JS Fiddle, Sometimes if you type some things that are a bit wrong, like you forget the semicolon or something, it'll put a little dot on the left-hand side, a little warning message. That's it running a linter that can give you a little bit of a hint that maybe you're doing something that might be an error. So pay attention to those kind of things. So I've been quite critical by telling you a bunch of bad things about JavaScript. Let's try and be more optimistic and focus on what's good about it. So what is good about JavaScript? Well, it's got first-class functions. People like that. It's got closures, which turn out to be a powerful thing for fancy programming. Prototypes are arguably a good idea as an alternative to classes. I think they're quite nice. And the creation of objects is really simple. It's nice, you've got an object-oriented language, you want an object, that's how you do it. Nice, simple, literal syntax, boom, you can create objects. Arrays, okay, just they've got a nice piece of equivalent syntax for arrays, and that's it. Right? That's the good core of the language. And that's the opinion of Brendan Eich himself, the guy who came up with it. He says that's what's good about the language. So we've had some criticism, some praise. Now we're going to have outright mockery. What? Does anyone know about what? Oh, good. Okay. I want to show you what. So what is a completely true account of some of the strange things that JavaScript does. If you haven't seen it before, you'll laugh, you'll cry, you'll hurl. It seems really, really strange. The thing is, there's actually good reasons for all of this stuff. This is someone deliberately trying to make JavaScript do things that it's particularly not good at, that exposes all of these silly quirks. It turns out there are good reasons for all of it, but it doesn't make the language look brilliant. It's a deliberate attempt to make JavaScript look bad. But it is quite funny though, so I'm going to show it to you. Here we go.
Go. All right, good. You guys know what WAT means? WAT. Exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors, as you would expect. And if you try to assign B to A with them undefined, of course it name errors, as you would expect. And what happens if you try to assign A to A with A undefined? Nil. Correct. Nil. WAT. Let's talk about Ruby. Ruby, unlike some other dynamic languages, does not have bare words, so you cannot just type words in and have strings come out, unless you define a particular method missing that does the right thing. And then if you type bare words, suddenly Ruby supports bare words. And in fact, it will even support bare words with bangs in them. And this is not deserving of WAT. This is actually a result of how awesome Ruby is. But if you ever actually do this, then WAT. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be?
Empty array.
Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object. If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because, you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to his string, and then we get wat1 a bunch of times. Fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Wet man. That's all I got. Thank you, guys.
So I'll just point out that by his own admission, that was a low blow. He was being mean there. He was deliberately picking examples that cause the type conversion rules to behave very strangely. There are rules about what happens when you try to add things that are not the same type. The general thing is it converts one or the other of them to a compatible type before it does the operation. Under extreme circumstances, that can cause bad effects, like you can subtract things that aren't numbers, so you get nan. You can have weird things where you're trying to take an array and turn it into a string, and it's like, So these are like edge cases. You should be wary of them. They're remnants of the language being a little bit sloppy in some ways, but they're just part of life. And I think that is actually, so this one here, if you want to actually know why it did all those things, this is a complete explanation of the underlying rules as to why it ends up being like that, right? And it's kind of unfortunate, but they make sense in some horrible, pedantic way, even though they seem absurd. Some references that I used to write this thing, but that is the end of that part of the lecture. So that's it. You've learned just about enough JavaScript to be dangerous, and in future weeks we'll start using it to actually make stuff.